difference in sound quality, I can compare the recordings to you guys. But like this mic, I had the version below that during COVID, like the Snowball. If anyone has like the blue Snowball at home, and that's the blue Yeti. It's better for like podcast recording or whatever else, but like it makes a huge difference. All right, so anyone want to read? I guess I could probably turn off my Charlie Brown. Nobody wants to read. No volunteer. Fine, Maddie. It will be mean if I don't call on you when you were the only hand up. I'm going to have Will to read the second paragraph. What?
Okay. Well, no, cool. That's fine. I guess. Wait, which one's longer?
Read the top paragraph, Maddie.
Architects and drafters make careful drawings of buildings that they design. The drawings represent how the building should be constructed. They show the thickness of the walls to where doors, windows, walls, and pipes will be. To make these precise diagrams, professionals often use special computer software. However, some architects still prefer to draw diagrams by hand at least some of the time. They use special drawing tools that look something like those in the drawing on the right, including a right triangle tool and a protractor. My voice.
Maybe you should volunteer.
Will, go ahead and hit us with the second paragraph.
Building plans are just one example of precise geometric drawing. Mathematicians have used these basic tools to draw accurate diagrams for other reasons. In mathematics, making a construction in the process of using a straight edge and a compass to solve a problem to create a geometric diagram. Constructing shapes that meet different guidelines can help you understand many of the specific characteristics of those shapes. In this lesson, you will be given important conditions to construct your own shapes.
As we talk about architects and drafters, if you are really interested in this, because I wish somebody had exposed me to more things when I was younger, one of our previous parents, alumni, Phoenix alumni, is an architect with their own firm. So if you were to look at their plans for a building, it starts with the site map, and then it goes through and talks about all the different floors. And guys, there is so much math involved before you ever get to breaking ground. But if you are curious about architect designs and drafts, it was pretty cool that he gave me this, and I'm like, really? You don't? He's like, dude, it's trash at this point. We keep them in a cabinet in case we ever need them again. But yeah, so if you want to see, this is one building. This whole packet to do one building, because you need all the different layers, all the different what about the plumbing, what about the electrical, what about everything. So not right now, but if you ever want to look at that, I will try to keep it somewhere in my room that you can get to. So what we're talking about today is constructing things. So you have a reference page in front of you that if you're using mid graph paper, yes, I said mid, you should be able to see through your graph paper to trace those lengths that I've given you on your reference sheet. If not, we can try to darken out the reference sheet, or I guess we could measure with a ruler if you really want. I was trying to make your life easier. But what you need to create, and not with your partner, just you on your own, is a triangle. What's triangle tell us?
3 points.
3 sides,
Yes.
well, and 3 points, with one angle that is 60 degrees, and one side that is 1.5 centimeters long.
Only
Go
one
for it.
or at least one?
What does it say?
One.
So, could you do more than one? Does it say only one?
Wait, which one's the quote-unquote mid?
These are really interesting propaganda notes. I doubt they're plus. If I was you, I'd probably start by drawing a side. Can we draw an angle without any lines?
No.
So I think we need lines, at least a line, before we can think about an angle. So whether it's your 1.5 centimeter, but guys, if you want to switch to inches, that's up to you, because 1.5 centimeters is pretty small. So if you'd like to switch to inches, you can.
What are we gonna be like? What are we gonna do with the lesson in centimeters or inches?
I mean, honestly, if you can decide, but at a certain point, inches might be too big for your paper. So then we'd probably go centimeters.
So like that.
But so guys, before our lesson tomorrow, plan to cut some pieces of wood to actually show this better tomorrow. I'm not going to cut in centimeters because that's really small. I'm either going to cut it in inches or some sort of larger scale. So I'm going to make a scale model of what we're using. Yeah, hopefully, I think today's going to be warm enough I can do some work in the shop.
Are we supposed to use protractors too?
So you can, or that reference sheet I gave you, those are accurate. So you can trust those.
Wait, this. Oh.
Yeah, so the one side has a protractor, but the other side has your angle references. In my wonderful drawers full of fun, I have many protractors, but I wasn't going to let anyone use them till we talk about them. So yes, I have protractors. Can you have them right now? No.
Sir, do you have a flashlight?
Then how?
I mean, I have my cell phone.
Then how are we
I
supposed to
gave you the reference page, Alex. Flip that sheet over. It has your angle sizes. I said that out loud.
May I borrow that flashlight?
Would you just have to like estimate the rows?
So you can lay this over. This is what we talked about. I announced this that if you're using graph paper that you can see through it. I called it mid graph paper because the really high quality stuff is thicker and you can't quite see through it.
I was very amused by that.
So before I will allow you to use a protractor, we need to know how to use a protractor because there are different protractors and those different protractors need used in different ways. So yes, starting tomorrow, we'll be allowed to use protractors really after today's class, but we got to talk about how to use them first.
Wait, can we bring our own protractors? Or like does it depend on like what it?
As long as you know how to work your protractor, sure, you can bring your own.
Guys, did the red one's mine. Oh, did we?
Compare your triangle with your neighbor. Compare your triangle with your neighbor. Are they identical? Degrees, 45 degrees. Here's a bunch of degree references. Hey friends. I gave you straight up degree references. So if you're trying to do 60 degrees, you can just do it. You don't have to use a protractor. The printed paper? That is. Or were you asking, does it need to be exact? No, it doesn't need to be exact. Friends, every piece of paper has two sides. It would be a great benefit to you if you observed both sides of that paper when you got it. So yes, one side has a protractor. I keep saying we're not using a protractor yet. On this side, it straight up gives you a 60-degree angle. The reason I don't want you using your protractor yet, there are two different 60s over here. That's what we're going to review. So if you make a triangle that has one edge of 1.5 centimeter or inches, a 60-degree angle, and that's all they tell us? Vivian, did you guys have the same triangles?
I haven't really drawn my whole triangle yet.
All good. Beatrix, did you and Maddie have the same triangles?
No. Well, no.
No?
She basically had like a line, so she
Like, well, I had a line, but then I had it on like one side.
Alex, did you guys have the same triangles?
No.
No. Interesting. Partners. Charlie, did you and Simon have the same triangles? Why?
Because,
What is? None of you had the same triangles.
well, technically,
Cora, what do you think is going on here? In a triangle, how many pieces are there?
one.
Three.
There are 3 if I imagine the triangle as a piece of pizza, then like that's one piece of pizza.
Sides and angles. As opposed to like
Sides divided by A equals B equals C.
This is not division.
Oh. Oopsie poopsies. Angles divide O.
Saying
not
divided.
right. It's a label.
Well, like, you know how we did like the original over.
I'm pretty sure there's at least 6 parts to a triangle. There are 3 sides that each have a length in whatever we're talking, whether it's centimeters or inches. So we need some kind of label. I guess I'll be American today and just put inches there. And then our angles all have sizes in
Degrees.
degrees. So there's at least 6 pieces. They told us one of our sides needs to be 1.5, whatever our label we're using. I'll default to inches, I guess. Maybe not, just because it's distracting me. Like, you might be able to learn like that, but I can't focus with you, like, doing a whole, like, X-Men sort of thing over there. So, the angle, they tell us,
60.
is 60 degrees. And what else do they tell us?
Nothing else.
Big old fat nothing. So why would our triangles not all match? We don't have enough information to make a match. You're randomly using 2 pieces of info out of 6? Of course they don't match. We're gonna skip B because you don't know how to use a protractor yet.
Well, way to rub it in.
What? Okay.
And it's just
New triangle. New triangle. Angle that measures. Ooh, sorry, not triangle. What does this mean? 4 sides. All right. So one angle measures 30 degrees, one angle measures 60 degrees. One side is 5 centimeters long. Go ahead and draw that on your paper. And again, you have a 30-degree reference. Like just given to you without using your protractor, you've got a 30-degree reference. At least I believe.
I'm gonna do 5
Yeah.
centimeters.
Do you have graph paper that you try to lay over top of it and see if it flows through exactly what I instructed you to do at the beginning of class? Hey, look, you can see it. Like if you hold it down and try real hard. But hold on, make sure that you're using the right. I don't know that that's the 30. Make sure it's either the 30 or the. Wait, can we draw an angle without a side? No, I would probably start with your 5 whatever side. Because I'm just gonna make my life easy. Make that like the bottom.
I cannot see nothing.
So we need a side with 5, and then a 30 degree and a 60 degree. I guess I'll go do this on my graph paper. So if you need walked through this, I'm going to get my 5 centimeters. I'm going to trace that. Ugly. Doesn't work out on this graph paper. Super nice, but whatever. And guys, you could also darken up the other paper if you really want to make these lines darker. Like you can do whatever. But all right, that's my 5. Look up here if you need walked through. I'm going to make my 30-degree angle be over here on the left side. So to do that, I'm going to use my 30. I'm going to line up my edge with that 30-degree angle that they give us. Making sure that my dot on the edge of the line lines up at the vertex of the angle. I see some people doing nothing, which I'm very confused about. I'm going to use a pencil because I'm not sure where this line's going to stop. Guys, we must label what we've put effort into. So also, I probably should have labeled my 5 centimeters. my 5 centimeters is not going to change. My 30 degrees will not change, but I don't know where this line is going to stop. Because did they tell me how long to make it? No. All right, I got my 30 degree. I also need a 60 degree. Now hold on. If I go to use this 60, you guys look up here real quick. If I go to use this 60 and I try to line it up like this, like this dot is oh, I gotta turn this paper all the way around so that this is the bottom of my shape. If you're not looking up here, this means nothing because now my angle is on the other side of my shape. So I gotta flip my paper around so that this lines up with the bottom of that 60. So then I can draw my 60 going up. Okay. Wait, what sort of shape was I supposed to make? A quadrilateral. I made this 60. But it looks like a triangle.
Because we only have 3 things.
Aquan?
What if you take the 30 and maybe change it a bit so it has like an extra side?
What do you? I mean, I can't adjust this angle. This has to point right
Erase like some of it and like make it like slightly like steeper or something. Maybe.
up just off the 30 line.
Yeah.
Yeah.
And then, like,
You don't want me to erase any of this.
No, just make it slightly steeper so that.
Make a little bend
so
bend.
that it still counts as one more side.
Now, instead of, I agree with you that we could make a 4th side that way, but I feel like it would look so much nicer if I made it a trapezoid. So if I erase my lines back down to where I can do this,
Guys, we're awesome. Sir, you're awesome.
you're fantastic.
Oh, really?
Well, I don't know. Do you have your work done on your paper?
I do.
Again, will we all have the same shape?
No.
How many pieces are there to a quadrilateral?
4.
At least 8. Right? We're not sure if that's the max or what. Like, we had 6 in the triangle. We got 1, 2, 3, 4 edges. 1, 2, 3, 4 angles. Man, geometry.
Well, actually, no. I'm pretty good at geometry. Depending on what I'm.
Well, now this setup is going to be way too easy. But you know what a Christmas tree's favorite math is, right?
Oh my gosh, you're
Geometry.
I have no idea.
Because geometry.
Oh, that's so funny. Sir, you're funny, but like,
But not. It's okay.
but not funny enough. What? That was
Not funny enough.
but not funny enough.
Let's go here
Sir.
to your reference page.
Okay, Jack.
Friends, advice from previous students. Just pretend he's funny. We're going to make some notes about our protractor. You might end up wanting a highlighter or two, and I think all your bins have at least a couple. I will take a volunteer. You don't even know what I'm asking.
No, I don't, but I'm willing to make that sacrifice.
You're going to make me use the cards. Why are there 2 sets of numbers on a protractor? Laurel, we haven't talked today.
So that, depending on which way the angle's going, you can still measure it.
Say more.
Because the top layer you would use for, like, on this page, the right angle, sorry, left, and then the bottom
Wait, right
side-
angles are all 90.
No, sorry. On the left side of the page, you would use the top.
You mean like this angle?
Use the bottom set of the 2.
Hey, you might want to grab a color if you want to match mine. I grabbed green just because it was what was within my reach.
And then on the other side,
So hold on, pause right there. I love what you're saying, but we need to put it on our paper. So Laurel is saying this left angle, this guy needs to use the bottom set of numbers. Why is that, Laurel?
because since where continue the line so that you're able to get the how many degrees it is.
The angle, like inside, like your angle, the vertex of your angle, where your rays meet, that must land on the very center of your protractor. So your vertex point from your angle needs to land. And the bottom of your angle, we need to turn our paper, turn our protractor, do whatever, so that this does what? This bottom needs to be,
Or base.
base bottom, needs to be what? But what's it need to point at, Laurel? This needs to point at 0. So, I have two options. I've got a 180 out here and I've got a 0 out here. I'm going to use the 0 for my left opening angle because my vertex needs to line up right there. My base needs to be pointing at 0. So then I can count up my inside numbers to figure out how big this angle would be. And I don't know, if we were to estimate, yeah, like 50 to 60 probably. So then if you want to draw a little picture up here of like that example. Now my green's a little hard to see, so you could do it like with your highlighter, I guess, if you want. So left opening angles, and I'm just going to kind of put it between left opening. We need to point at 0. We need to land our vertex. And then we can measure based off that. So, Laurel, you want to keep talking about this right but not right angle?
And then you would, on the right side of the page, then you do the same thing except with the top set of numbers.
So, again, vertex needs to land at the that's just always the rule. Right? Vertex point, landing on the vertex. My ray BC needs to point at 0. But with this angle opening to the right, when I bring it up here to point at 0, we got to use which sets of numbers? The outer. Right? So we got to use this set of numbers because of that 0 being so important. We got to make sure that our base ray goes to 0. So if you want to draw an example of the blue angle up here, I'm actually going to try to grab my brighter blue. So base points at 0. Vertex is where it should be. And then we go up. So when using actual protractors, this starts to suck. I'm serious, because there's like 18 different kinds of protractors. And this is why we're not using them until we talk about them.
Caleb, McGill, and Lane Bergen, please come to the Perry office.
If I grab this protractor, where's my vertex point need to be positioned on this protractor?
On the base.
Like down here? Ooh, in the center of this dot? So, if I place center, look for my, wait a minute, now my outside set has my zeros. Not every protractor's made the same. So you can't just default to inside, outside. You got to actually look at it and say, my 0, okay. Then I'm using my, are we using inside or outside numbers? Outside. Make sure your 0 lines up. Make sure your dot lines up. So this would measure about 58? Yeah, sure looks like it. So like 58 degrees. But wait, there's more. This protractor. Where would my vertex line up? It also has a dot like drilled in it, right? So dot, line up your 0. But wait a minute. This black Wait, is the black line 0? Or is the dot 0?
The dot. The vertex. Sir, go to the right a little bit, like with paper.
I can't lift this. So if you look at this, the 0 is the line. What? So wait, should I be... That dot isn't even what I want to use? Why put a dot there then? What?
So you can
Get out of here.
you can
Disc golf disc that. What about this protractor?
the line.
You use the
The line
bottom
doesn't
of
exist.
the
There's no line. What line?
Wait, flip it over.
First off, the numbers are backwards. Flip it over. All right, now where do I position my vertex? What line?
Middle line.
Oh, this line. Okay, so like this. Ah, so now with these, there's no hole, but I can line up my base ray on literally the very bottom edge of that protractor. And now am I using inside numbers, outside numbers? Inside. And yeah, I mean, it looks pretty darn close to 60. The other one was slightly a bit more accurate, but I could also draw this line farther. Further. I don't know. I don't know which is right. I could draw this line longer, and then it would actually make it up here, right? So if you're like, but I can't see where this goes, grab your straight edge. Doesn't have to be a ruler, anything straight. Extend that line, and then you can continue on with trying it. So over here, if we line this up, get our 0, follow, how big does this angle look like it is?
39.
40.
Yeah, I mean, I'm going to go ahead and just let this guy be 40 since we were so accurate about the other one. 40 what? Degrees, because remember, there are also radians. So whatever notes you want to make about making sure the vertex actually is at the vertex, and 0 is your base angle, and then it gets even more fun. This is the S tier tractor, right? Not just protractor, it's S tier. So you can use full, 2 protractors together and get your 0, 0, get your base angle. So these are also very useful, but what you see more often than these is just your regular protractor. So I would say as a class, we're probably going to default to using these gray protractors just because quite honestly, I think they're the best that I have. If you really like having a protractor with an arm on it, that's fine, but you've got to remember that your vertex goes in this hole, and if you grab one of the other random protractors that I've ended up inheriting over the years, you got to make sure you figure out how it works, because I have a variety of protractors. You got to double check that you're using it right. Questions? So on your homework, it's going to tell you to get a protractor. By AO this afternoon, so I think I'm just going to run home after game lunch. I will have protractors back on the back counter, hanging off. It's like a little coffee mug tree thing that we don't use at home anymore, so I'm going to bring it and just hang stuff off it back there. If you borrow a protractor and you take it off of that, what should you do when you're done with it? Bring it back and put it back. Should it get left in Miss Pettigrew's room? No. Should it get left over in Mr. Estes' room because it's so far you just don't want to walk? No, get off your lazy butt and bring me my tools back. That or don't borrow them. Hey, we're not out of time yet. We're not. Oh, I guess I can stop. I was going to do a mind trap real quick.
Wait, what's the mind trap?
To get you guys incentivized for Friday. How do I get back to my recording? Seriously, I can't get my little framey. There's my